I'm going to work this trig substitution integration problem. When you're dealing with trig substitution, it usually involves a radical, and it usually has something like a number minus x squared or x squared plus a number or something like that. And the goal is to try to get your radicand, this interior of your radical, to look like one of your Pythagorean identities. And your Pythagorean identities are the ones like sine squared plus cosine squared equals 1. And this one, if you finagle it around, if you move that sine squared over, you notice I have 1 minus sine squared, which is a number minus something squared. And here I have a number minus something squared. The only difference is the number here is 16 instead of a 1. So what we're going to do to fix that is simply multiply this entire equation by 16. And if you do that, you get 16 cosine squared equals 16 minus 16 sine squared. And now it looks a whole lot like my radical 16 minus something squared. And then maybe to kill this dead, I'm going to change 16 sine squared into the quantity 4 sine theta squared. And then here's where the substitution comes in. If I take out my x and I plug in its place a 4 sine theta, then the interior of this radical will look like this Pythagorean identity. Pythagorean trig identity. One thing you need to remember is when you do the substitution, you always have to, wow, that's a horrible integral sign, you always have to account for the dx, and that's one of the mistakes I see a lot of people make with trig substitution. So if I plug in 4 sine theta, I have 16 minus, and I'm plugging this 4 sine theta in for the x, so when you square that, it will become 16 sine squared theta. And you do need to account for the dx. So if x is 4 sine theta, then dx is going to be the derivative of that, which is 4 cosine theta d theta. And so I need to substitute 4 cosine theta d theta for the dx. You must remember to account for the dx. And then we start cleaning this up. The whole point of the trig identity of the substitution is that I can now say that 16 minus 16 sine squared is the same thing as 16 cosine squared. And then I have my times 4 cosine theta d theta. And the square root of 16 cosine squared is 4 cosine theta. And I still have the 4 cosine theta d theta, which turns into 16 cosine squared theta d theta. And so the idea behind the trig substitution is to get rid of the radical to find a way to simplify your integral. Let's see, I'm going to pull this over here. When I have constants, I usually pull them out, so I'm going to pull that 16 out, and I'm left with the cosine squared. The way you integrate cosine squared is you use a power reducing identity. Cosine squared is the same thing as 1 plus cosine 2 theta divided by 2. Again, I have a constant. I'm dividing by 2, so I'm actually going to pull that 2 out as a 1/2, which gives me 8, 16 times a half. Antiderivative of 1 plus cosine 2 theta d theta. And now finally I can do the antiderivative. The antiderivative of 1, and now this is d theta, is just theta. And the antiderivative of cosine 2 theta is going to be sine 2 theta divided by 2. The 8 on the outside stays there. Don't forget the plus c, the constant of integration. And now I have integrated it. So the anti-differentiation is complete. But remember, we started with x's. We need to finish with x's. You're not allowed to stop with just thetas. So now I need to go back to my conversion, my substitution equation, which was x equals 4 sine theta. And I'm going to pull that down. And we need to use that to get rid of the thetas and get this equation back into terms of x. So if x equals 4 sine theta, that means x divided by 4 equals sine theta, which means that theta is the inverse sine of x over 4. And that's what I'm going to plug in for the theta here. I'm going to take out the theta, and I'm going to plug in inverse sine x over 4, or you could write arc sine of x over 4. The sine 2 theta, though, is going to be a bit of a problem, because what I have here is sine of 1 theta is x over 4, but what does sine 2 theta equal? Well, the way we're going to tackle that one is I'm going to take out the sine of 2 theta. Since I started with 1 theta, I really want to have my trig function with just 1 theta, so I'm going to use my double angle identity. Sine 2 theta is the same thing as 2 sine theta cosine theta. That is still divided by 2, so those 2's are actually going to cancel. And I will go ahead and leave the theta in there for now. So it's theta plus all of that, plus a constant. And now I'm going to substitute in. So I'm going to plug in my inverse sine or arc sine of x over 4 for my theta. So theta comes out, that's arc sine, I'll stick with inverse sine notation. Inverse sine of x over 4. Here the 2's are going to cancel, so I'm not worried about those. Sine theta we know is x over 4, right? Because I have here sine theta is x over 4, so I'm going to take out the sine theta. I'm going to plug in x over 4. And if sine is x over 4, what would cosine be? I now need to substitute for cosine. And the way I do that is if sine theta equals x over 4, what I do is I draw a triangle that fits that. Sine is opposite over hypotenuse, so sine theta means the opposite of theta is x, the hypotenuse is 4. If you use your Pythagorean theorem, you end up getting the root of 16 minus x squared for your third side. Now if I want to know what the cosine theta is, well, here's my triangle. Cosine theta is adjacent over hypotenuse, so cosine is going to be the root of 16 minus x squared divided by 4, and that's what I'm going to plug in for my cosine. So it's inverse sine of x over 4 plus x over 4 for the sine, and then the cosine is the root of 16 minus x squared, all divided by 4. And then don't forget that it's all of that. There is an 8 on the outside, and then plus c. And finally, we have completed this trig substitution problem. So there we go, and maybe I'll highlight the stuff that I substituted just so you can keep it straight. I took out the sine theta, and I plugged in x over 4. I took out the cosine theta, and I plugged in root 16 minus x squared all over 4. So there you go. That is a trig substitution problem. They are a bit lengthy, and sadly, this was probably one of the more straightforward, simple ones. They're not short problems. So there you go. Hopefully that will help you out some.